Okay, Assalamu alaikum wa rahmatullah. We have here a very simple problem. We would like to share it with you regarding now how we can solve this problem. We have here using the figure part selected by your instructor, sketch a free body diagram. So the first one required here is to make a sketch a free body diagram. This is the first requirement. Okay, and this is number one. The second, compute the magnitude and direction of each force using an algebraic or vector method as specified. So you will use algebraic and the vector method for solution. Now let's do the free body diagram. For a free body diagram, we just re-sketch again this figure, but without making, how to say, with no full details. I will show it to you nicely now. Here it is tangent. Oh, it should be tangent like this. Okay. Now we have a tangent point here. This is called A, and we have a tangent point here. This is B. Now we have the center of this rod or cylinder, which is resting on a inclined wall, you can say, and we have here the radius of this cylinder, or whatever, bar or cylinder, say circular bar. Now what we have here, we have a force showing in the direction. We have for this cylinder, we have its gravitational force is directing downwards like this. Okay, and it is about 2 Newton or 2 kilonewton. Okay, and we have this wall is having this is an inclined angle of 30 degrees. Okay, and we have from the opposite 60. Maybe it's not showing 60, but okay, we will assume that it's 60. The 60 should be bigger than this one anyway. Now we will use a method, it's called the vector method. So here we try to form a closed triangle showing unified direction. Okay, how is this? First of all, we'd like to say about something here, like for example, if I have an angle, okay, let's say this is an angle 30 degrees, and there is another angle, but this another angle, it has a special design that the side of this angle, if we extend it, we will find it will be perpendicular to one side of this angle, and the other side of this angle, if we extend it, we will find it is perpendicular to this one. In this case, we will have the same angle. So do we have like this? Yes, we have. Look at this figure. We have here a reaction coming from A, perpendicular to the point A. It is directing in this way. Here is called RA. RA. Okay, and we have another one here. It's called RB. Okay, let's form from here. We will form this kind of triangle. This is for the gravitational weight force, which is representing the weight of the cylinder, 2 Newton, and if this one represented here, it will become like this, and this one RP will become like this. So this is RB, and this is RA, and this is 2 Newton. Now what are these angles? Okay, these angles you can figure it out from here. This angle, this side of this angle is perpendicular to this angle, to this side of this angle, and the other one is perpendicular to this one. So we have the same case as here. So this one will become 30. Okay, let's reflect it here, this one and here, so it means we have 30 here. So here is 30. Okay, and since this is perpendicular, because this is perpendicular to this one, so 90, so it is here 60. Now it is very simple. This is by using the Pythagorean theorem. Sine, let's say 60 is equal to the opposite, which is 2 over, sorry, not 2, the sine of 60 is RA over the hypotenuse, which is 2. In this case we have RA is equal to 2 into sine 60. Similarly, we have for sine 30 is equal 30, the opposite is RP over the hypotenuse, which is 2. In this case we will have RP is equal 2 into sine 30. So we have this force and this reaction force. We are done. Of course, it will be in kilonewton. Thank you very much.